Hello, my name is Juan Felipe Martinez from grade 10C and this is my evaluation. The first question is this one. So, the main difference between RAM and ROM is that RAM is the type of memory that can be directly changed by the CPU. All the information gets to it. But if the power is lost, then all the information is also lost. ROM is another type of memory that can only be accessed by the CPU. But the difference is that in this case, if the power is lost, then the information is not lost. So in this case, the main difference would be that ROM is volatile, where the information is not lost when the power is out, and RAM is non-volatile. So this means that the information is lost. So the function of databus is to exchange or to send information from one part of the computer to another. This is mainly from the CPU, which is the main system of the computer, to the CU, which means is the control unit where the information is processed, and then the function that has to be needed is done. The second type is address bus, where additional information is sent so that the instruction can be executed. So the address bus will send additional information that is needed by the control unit so that it is executed perfectly. So the main role from memory management is to organize all the information from the primary memory, also to know which data has to be processed by the computer, and lastly to know every location from the information that is in the CPU. So why computers? Well, all computers use binary. Well, this is simple. Binary is like the universal language of computing. It is done, or it is made by bits, which is the smallest type of information that can be found. This type of language is easy to decode, as it is conformed by 1 and zeros. The 1 means yes, or where there is information, and the 0 means no, or where is no information. So this would be really easy to decode by a computer, making it function really fast. So the first conversion that we need to do is from binary to decimal. This is our binary number. So what do we need to do? We have to multiply each number for the powers of 2. So the first number, 2 to the 0th, 2 to the 1, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. As when we multiply any number by 0, so this can be cancelled, as the result would be 0. Then 1 times 2 to the 0th power is 1. Then we need to add 1 times 2 to the second power is 4. 2 to the 4th power is 16. And 2 to the 7th power is 128. This would give us a total of 16 and 4, 20, 21, 1 and 9, 2 and 2, 4, and 1, 149. So the last number would be 149. The second conversion is to change this decimal number, 477, to a binary number. For this, we need to subtract the nearest 2 to the nth power number. In this case, would be 256, which means that would be 2 to the 8th power. 477 minus 256 would give us as a result 221. Then the nearest nth power of 2 would be 128, 2 to the 7th power, 128. That will give us as a result 93. The nearest number to 93 would be 2 to the 6th power, which is 64. That subtraction would give us as a result 29. The nearest power would be 2 to the 4th power, which is 16. And the result would be 13. Then the other would be 2 to the third power, which would be 8, and will give us a 5. Then 2 to the second power will give us a 1, and lastly 2 to the 0th power, that would be 1, which means this is 0. Now we're going to take these numbers: 2 to the 8th, 2 to the 7th, 2 to the 6th, 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, and 2 to the 0th. Now we are going to take these numbers, and this would be our number 1 in the binary code. So this would be a 1. Okay, there is no 2 to the 1th power. Then 2 to the 2nd would be another 1, 2 to the 4th another 1, 2 to the 6th, to the 7th, and to the 8th. And the rest of the numbers that we didn't use would be a 0. So the last, our binary number would be 1 1 1 0 1 0 1 0 1. This would be our binary number. Now our third conversion is hexadecimal to decimal. First, we need to know that in the hexadecimal system, f equals 15 and c equals 12 in the decimal system. So as this is in a 16 base number, we need to multiply by the powers of 16. So this would be 15 times 16 to the second power plus 4 times 16 to the first power plus c, that would be 12, times 16 to the 0th power. Then this would be 15 times 256 plus 4 times 16 plus 12, as 16 to the 3rd power is 1, 12 times 1 equals 12. Then the result between 15 times 256 would give us 3840 plus 16 times 4 equals 64 plus 12. So our decimal number would be 3580 plus 64 plus 12, and that would give us as a result 3916 in the number 10 system. So which means f for c in the hexadecimal system becomes 3916 in the decimal system. The third conversion would be binary to hexadecimal. What do we need to do here? So first we need to divide the binary number in groups of 4, 2, 4. This would be one group, 1, 2, 3, 4. This would be another group, and these last two numbers would be another group. So what do we need to do here? We need to divide these three groups. Then each number, the first number, would be multiplied by 2 to the 0th power, the second by 2 to the 1th, the third by 2 to the 2th, and the third by 2 to the 3rd. We will repeat this process in the other group: 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 to the 3rd. And the same process in the last box. So 2 to the 0th and 2 to the 1th. So we cancel the zeros, as the result would be 0. And 1 times 2 to the 1th power would be 1. And 1 times 2 to the 2nd power would be 4. 1 times 2 to the 1th power would be 1. 2 to the 2nd power times 1 would be 4. And 2 to the 3rd power times 1 would be 8. Lastly, we have 1 times 2 to the 1th power, that would be 2. So we need to add each numbers that gave us in each group. 4 plus 1 equals 5. 8 plus 4, 12, plus 1, 13. And lastly, we got 2. So as 13 in the hexadecimal system is a letter, which is D, the final result would be that this binary number is 2D5 in the hexadecimal system.